Hello everyone. Welcome to the course Microsensor Implantable Devices and Rodent Surgeries for Biomedical Application. I am Rathin Joshi. I will be mostly discussing about the neural signal processing aspects and some of the applications. I am a PhD student here at Abyss Lab DESC IISc, and in today's class we will be looking at, as I mentioned, some of the applications, how to realize that application, how to process the signal for that particular application. You have already this course would be conducted by Dr. Hardik Pandya and Dr. Shabri Girishan, who is a neurosurgeon. Some of the aspect which has been already covered in theory, I would be providing a little bit on MATLAB simulation and some of the signal computational approaches, how to work. Of course, not for all application it is not possible to explain each and everything, but we'll try to give the gist of the processing, or the computation what we do, that will help you to decide the flow for that. So before going through each and every problem, I'll just quickly show you some of the applications, some of the problems, and what is the context. Always signal processing without knowing a context, or processing any biomedical data without context, without knowing experimental protocol, will not lead to some of the conclusive inferences which will be helpful. So considering this fact, we'll just quickly see that how things have been done, what are the signal, how they have taken, at which anatomical level it has taken. Mainly, as I mentioned, I'll be discussing about the neural aspect. So I would be talking about EEG, ECOGs, SEEG, what are all these things. We'll quickly see that in today's lecture, and then how it is useful to further make devices, sensors, and overall systems and all. So if you can see my screen, here there are different modalities at which your biopotentials are taken is shown. Here you see EEG is the first one, which is recorded from the scalp and which is a non-invasive technique, and that's why it is the primary method to take for any neurological disorder. If you go to a doctor or neurologist or neurophysiologist, epileptologist, etc., the first thing would be get your EEG done. Why? Because it's a non-invasive. You don't need to perform any surgery for that. There won't be any risk of tissue damage, infection and all. However, for some of the scenarios or some of the conditions, you have to do the surgery and go deep in your head or skull. So then you will take ECOGs, which are taken from the cortex or skull. Here you see this is like a nice illustration where is scalp. So this brown color region is the scalp, whereas this is your skull, this is dura, this is pia, this is grey matter, this is white matter. Now what is this grey matter, what is white matter, how it looks like, everything we will see when we perform surgery. Now it is as you already know that for neurological research, as Professor Hardik mentioned, this is the flow for neurological research, right? To prove or any put any new things into the perspective, as brain is very very sensitive organ and comparatively less explored, there is a flow for research. First you start with rat, then cats, monkeys, which is also known as non-human primates, and then you go to the humans. So this is the flow. So we will be showing you in this particular subject rodents neurosurgery as the name of the topic, and we'll see how all this anatomical region looks like in that particular surgery. And also there is a strategic reasoning or rationale behind going at which level. Like if EEG itself is enough, we don't have to do any kind of surgery, we don't have to go subdural or intradural, or we have to for some of the things we even go to the depth, which is like in the white matter, right? So that is there are some problems, there are some conditions known as Parkinson or something, for which you have to stimulate your brain using some current. Also there are some other memory loss and all. There are research going on that basically, in a layman term, in a simpler term, it will rewire or it will restructure your brain network so that you can get your proper connections or network electrical network of the brain going. It's all about synchronous neuronal activity, like as you see for epilepsy also. If there are neurons which gets fired in a synchronous fashion and in an uneven way, then it will happen that you will be getting an epileptic seizure, right? So it is all about how your neurons, and there are different types of cells available, pyramidal cells, and some cells will inhibit the activity of that, and proper balance is required for a proper brain functionality to work. So considering that, we will decide that which modality to do, how deeper we should go based on your condition, problem, and also these all are biopotential, what I have mentioned. It's like mostly you will get a one dimensional temporal traces. Also you can perform some of the imaging technique, right? MRI, fMRI, or spectroscopy technique and all. Every technique or modality has its own pros and cons and conveys a significant amount of information. This is a very nice summary of the BCI techniques which has been used, how better you can go in terms of temporal resolution and spatial resolution. There is always a trade-off. So if you can see here, this looks the best, right? The ECOG or SEEG, which has a very less temporal resolution. What do you mean by temporal resolution? The moment something you do some particular task, your brain reacts to that, that can be captured in your brain waves. In a very simplistic term, suppose like we are taking a normal EEG from your forehead. Now this is called forehead. Which region of the head, what it is called, what is nomenclature, will be covered by Professor Pandya. That is like 10-20 system and all. That's a prefrontal, frontal, central, parietal, then temporal and occipital and all. For particular experiment, you should know where to put the electrode. A very simplistic example I am giving for now is, if you are recording your EEG from here, first of all, to record any biopotential, you require 3 electrode. Okay, one is just a second. Yeah, one is active electrode. Okay, second one is reference electrode, and third one would be ground. Okay, now why this 3 electrode? This 3 electrode will be inputted or given as an input to your acquisition system, and this is true for any biopotential, not only EEG. Okay, the same is true for ECG. You all know, right? What is ECG? It's heart, like EEG corresponds or give you information about brain state of the brain, right? ECG corresponds to heart, right? Some of the movies or somewhere you would have seen, there will be variation, suddenly it goes flat line, so that heart stops working. Similarly, there is something called EOG, electrooculograph, used for eye tracking and similar application. Also, there is something called EMG, electromyography, when you have movement disorder or something like that, your muscle movement, right? So, as I am just giving you an analogy, this is eye, this is muscle. Okay. So this is organ, this is biopotential. All this thing recorded using active, reference and ground, this 3 electrode, which is decided by acquisition system. It is nothing but electronics module. Okay, in this course only, one of the my colleague would be explaining about how to design electronic module and all this thing. So then electronic module, what it will have, finally the things whatever used here to capture the data. Data is our biopotential, which is a continuous, or I should say analogous quantity, but we are doing all the processing or signal processing. What we will be explaining would be in terms of numbers, digits, right, in your system. So then sampling and all will be done, but the heart of the acquisition remains ADC. Okay, and if we, I'll not go into too much of detail of electronics, but in that there will be IN, instrumentation amplifier. Okay, so there are several things, what is sampling rate, what is resolution and all. Based on your application you can decide all this thing. So yeah, coming back to, like, this is just a brief overview of the things, what electronics module or how many electrodes are used and all. So I was explaining about temporal resolution, and for that I was telling that we will put the electrode on the forehead here, and let's say this is just a trace. I ask subject to blink at this particular moment, and then this is a normal thing. Then if you can see me, the electrode would be placed on my forehead, which is yeah, if you can see me, if one electrode is placed here, which is on your forehead right here, and you can use your ear lobes or mastoid as a reference and ground. So like that, if you can put your 3 electrode active on forehead, okay, reference and ground on earlobe, okay. So if you can keep like this, okay, then and you are recording EEG, let's say this is some baseline, and the moment you blink you will get this kind of pattern, known pattern, okay. So there will the moment you blink here and the moment the pattern came, that is nothing but your temporal resolution, okay. So that is what temporal resolution is all about, how fast your device can react based on your action, or how fast your device can capture the moment of your brain waves based on a particular action. So further, there is a spatial resolution, right? Finally, the data or biopotential comes out of the head, but where the action happens, let's say you are taking EEG from this particular location, right? But there will be some neurons here which is contributing to this location. There will be some neurons here which is contribution to this location. There will be some neurons here contribution to here, right? But and on a different intensity. So how to identify the data which is obtained from here, it has how spatially the data has come. So that can be identified if you have a proper spatial resolution. So if you can see now in this particular graph, here EEG is there, but has a poor spatial resolution, excellent temporal resolution, EEG. A poor spatial resolution, excellent temporal resolution. Where you go ECOG or SEEG, which is taken in the deeper region of brain, you will still get a same temporal resolution but your spatial resolution is also good. Then it is the very good thing, right? Why should we take EEG? SEEG or ECOG gives a really good result with a great excellent spatial resolution and temporal resolution. However, that comes if you see the color of the dot, EEG is completely white, whereas the SEEG or ECOG is black, which shows the invasivity. So then the data is recorded from your brain, which means brain surgery is performed, which comes with its own pros and cons. So there is a trade-off. You have to decide that which modality you want to record and how you want to proceed. Of course, there is a NIRS is there, near infrared spectroscopy, functional MRI, PET scan, and all different imaging techniques are there. So you can explore it by yourself. But considering there are multiple parameters, as I said, here just 3 are considered: spatial resolution, temporal resolution, invasivity. Much more parameters and much more condition specific parameters are there. So based on that, condition specific as such, if epilepsy is there, you should go for one particular modality. If brain stimulation is there, you should go for one particular modality. If Alzheimer is there, anxiety is there, depression is there are several neurological disorders. Based on that, you have to decide. It's a subjective measure or subjective way of treatment which needs to be identified, and for which neurophysiologists, doctors and everyone comes to the picture. Okay, so what are the applications and all? So what we can solve if we can do the signal processing with a little bit of knowledge of mathematics and fundamentals of mathematics. So I'll just show it to you, the applications here. What are the basic applications which we'll be looking at to solve in this particular course? So first thing is epilepsy. So epilepsy screening, we will see how we can automate the data which is obtained using your entire head, and we will also identify where is the origin, right? Very important, in your head, or where the uneven activity starts, how it progresses. Based on that, there are different types of epilepsy. There is something called focal epilepsy, focal, where focus is identified, something called generalized epilepsy. This all things would be covered by Professor Hardik in his course. I'm just going little bit fast. Where additionally there is something called drug efficacy, right? You have epilepsy, you are taking anti-epileptic drug. Which anti-epileptic drug is good for you or bad for you? So screening of anti-epileptic drugs. How do you identify that? Let's say you are currently you are in a normal state, or you are having an epilepsy. Okay, this is a normal state. This is epileptic state. Okay, then AED is given, anti-epileptic drugs, and now again you came back to this normal state. This was normal 1, this is normal 2. AED 1 was given. Let's say AED 2 is given. Okay, and you have come back to another normal state. Now this is also normal. Now what do I mean by normal state? When you record the data, it will not give you any uneven or unintended temporal traces of EEG or ECOG or SEEG, right? There won't be any uneven disturbances of electrical networks and all this thing. So this is also a normal state, this is also a normal state. Let's say this baseline has a value of 50 microvolt. This generally EEG is recorded or measured in microvolts, whereas this is also one baseline got restored after AED, it is having 30 microvolt, whereas here it is around 80 microvolt. Now this is also a baseline, a normal EEG, this is also a normal EEG. Which one of them is better, right? So that you can identify by recording and processing the signal to know that okay, this baseline is this is this. But however, in this particular value also there are some discharges which can which is progressing towards the epileptic waveform or epileptic pattern. So to know the pattern, quantify the pattern, which channel it is coming and all. So all this you have to perform an analysis that is known as spatiotemporal analysis and all. At some point of time I will share the paper with you. So you can identify. First we will just go through the entire process, then I will share the paper with you so you can identify. Further, one very important thing is sleep. Now for your system or computer, laptop to work, you have to turn it off, or you should have log off, or restart it, right, at one particular point of time. Same goes for our body. All humans at any particular age needs at least 6 to 7 hours of sleep to get going, and everyone should. So how, and sometimes it feels that even if you slept for 4-5 hours, you feel that wow, I had a great sleep and now I am ready for any kind of work. Whereas in some particular point of time it happened that even after you have slept for 8-9 hours, you feel like disturbed, dizzy, tired and all. So how to identify that? So there is a science for that. There are sleep studies and sleep labs available, where regular studies on sleep with different intervention happen, that at which particular luminance or light a person should sleep, under which particular sound a person should sleep. Generally when we sleep, we don't prefer any sound, but if a sound or auditory stimulus in a neurological term if provided, then which is in sync with your brain waves, then you will get a better feeling, or better kind of experience of the sleep. So in some of the airports, in snoozing zone and all, if you go, there will be some water drop or similar sound would be played. That is to give you a better experience, because you might not get a complete sleep, but in limited period of time you should not feel completely tired or something. So there is a science for that can be done, sleep quality assessment and improvement. So insomnia and all sleeping disorders, there's something called sleep apnea as well. You can identify the sleep quality using not only EEG but also snoring sound, which is sometimes you might feel that snoring is annoying, but when you combine it, snoring sound with EEG, you can get a very significant information about your sleep quality. So that is also important. Also fatigue detection. I'll be keep on speaking in this particular class, and what if you get bored? So whether you actually get bored, or when should we take a break? Not only this class, if I talk about if you are working in one particular company, okay, there is something called Pomodoro technique, a Japanese technique. You work for 25 minutes and take 5 minutes break. After 4 break, or you take one big break. So do we really have to follow, or is it subject specific? So my experience is, if I work on one particular thing which I like, then I can work for 3, 4, 5 hours also. It depends on person to person. So whether when you are actually fatigued, when should you take a break? This will be used in any of the multinational companies for productivity management. This all can be done by just wearing a small helmet or small headband, just a normal band like you used to wear, and it will say, okay, now you can take a break. It is possible. Okay. Also, some other application, but so far this 5 application whatever I have talked so far, these are all application of free running EEG. Okay. Now when I say EEG, other parameters can also be there, or other modalities can also be measured, like as I mentioned, for sleep quality and improvement snoring sound. So these are free running EEG. What do I mean by free running EEG? Free running EEG, normal EEG is being recorded without any kind of intervention or without any kind of stimulus. Of course, when you put for improvement, it is a stimulus based EEG, but otherwise it's a normal free running EEG. When you add EEG plus stimulus, okay, any stimulus can be audio, it can be video, right, it can be any kind of let's say particular fragrance, it has its own importance, I will come to that, or it can be a touch generates somatosensory evoke potential. All this thing EEG plus stimulus will result in evoke potential. When I am speaking, you are listening, EEG will be speech evoked EEG. You will think something, it will be some other EEG. If you see something and suddenly you see something which is unexpected, there are few potentials or evoke potential will get generated. It is called evoke potential. Okay. Not only evoke potential, if specific to one particular event you are getting your response, it is called ERP, event related potential. Okay. First 5 are the application of free running EEG, more or less. When I say quality assessment, it is a free running EEG, whereas the other thing, related, this brain functionality, coma recovery, all this thing comes under evoke potential or ERP related experimentation. So this is like free running EEG, then ERP, then some other combinations of both as well. So further, it is coma recovery index, when the person is in coma or brain dead, right? How much chances that the person will again come back and resume the normal life. So that can be identified using EEG. Also, there is a brain functionality assessment in which sensory system assessment. So this, if I talk from now here, this is all EP or ERP. Now all of you should know what is EP and ERP, evoke potentials or event related potentials, right? So then sensory system, what are the things we will be measuring? Mostly it will be hearing screening, cognitive parameters, attention, working memory, all this thing. I will show in the scripting as well using MATLAB how we can process that. And further, there are, as I mentioned, there are several disorders for neurological assessment, which is like Alzheimer, like a kind of memory loss, schizophrenia, you will feel like anger and all. Also autism, you will find it difficult to speak. If you aware, and the several cases were there in movies also, it has been shown, Burfi movie. So that's a autism spectrum disorder, which is really a challenging condition. Also there is ADHD, hyperactivity disorder, depression. In the current era, this mental health is a very concerned topic. So depression is also one of them, so as anxiety. So all this thing can be identified, detected, and once detected, it can be quantified as well, that whether whatever therapy you have been part of is correct or not. So then neurological disorder assessment is also can be performed. Also one good like couple of new thing which is emerging out, right? It is gaming EEG. Of course, again it's EP or ERP. Now what do you mean by gaming EEG? I hope most of you are aware about the single player games and all. If not, please search about that. So then gaming EEG, where you can, there are something called single player games or action games. Person with schizophrenia, okay, if you record that how many enemies that person has killed, or how hard or with very like how forcefully that person has clicked on the button, okay, that would be different than a normal person. So again a simple normal game you can make and record EEG simultaneously, you will get an inference that whether the person has little bit of what is the degree of schizophrenia, how schizophrenic that person is, because that has its own, all this Alzheimer's, schizophrenia, ADHD and all has their own consequences, right? And all are really really important problem. I have only put some of the critical applications which I can easily explain to you. I am not going into the detail. Of course, apart from this, if I want to consider, and as this course we will be focusing on invasive experiment, we will be looking at DBS also. One of my friend would have already covered a few aspects of DBS, which is a deep brain stimulation. There are own benefits and disadvantages as well to go deeper in the brain and perform the surgery, or perform the surgery and then provide an electrical stimulation and check how it has resulted or how it has affected your particular brain region. And of course all this thing has to be done under a proper ethical approval. Without that you should not perform any experiment for animals as well. So that is the gaming EEG. And furthermore, if we move ahead, there is something called neuromarketing, which is again a niche topic. Recently I have come across some of the paper on that, in a very simplistic term, if I wanted to say, you are scrolling through your Amazon or Flipkart websites and one cap has been provided to you which will continuously recording your EEG. Then by just scrolling through your thing, EEG can identify that yeah, this person is more likely to buy this item than this other particular item. And then all of you know, then the era of AI and ML, now people even without the EEG, currently we are getting exactly appropriate appropriate options or recommendations. Then if we can even merge this kind of modality, it will even help. So this is like another application which we will be discussing about. And this is like some of the application. How do we do that? So to identify that particular thing, I'll show you that what are the applications. Not every application is possible to cover in this particular course, and considering the time factor, I would be explaining 2-3 of this and demoing it, how to approach and all. Using which particular modality we will achieve that application, I'll talk about that. Also when you see the signal, how to see, what to see, using which mathematical technique we will do that. This all like neural signal processing, biomedical signal processing, even AI ML are the advanced name of mathematics. So then what techniques we will be using of mathematics, and further how we will be reaching there, using which platform we will be reaching there. So this thing I will cover. So just a quick summary of what we will be doing. In this course we will be checking hearing screening, cognitive metric screening, epilepsy seizure classification, some of the rodent signal. Rodent signal means ECOGs, SEEG and all taken post neurosurgery from rats, and how to draw neural inferences. I have come across several situations when we have a data, and a lot of data rather now, because everyone has started putting the data for making it open access for better analysis. But then the lack of interpretation ability or physiological mapping knowledge, they won't be able to come to any particular conclusion. So how to interpret the obtained data and present so that it make neural sense, right? So that is also again a very important thing. We'll be looking at that. What are the things we'll be looking at? We'll be looking at evoked EEGs, ERPs, free running EEGs, free running ECOGs, SEEG as well. SEEG is nothing but stereo EEG, which is like a deep region of your brain. Very small incision will be made, electrodes will be dropped, penetrate to your brain, and then you will get the recording or you will get the response. And like in motor, you have a steering, right? Stereo. Like that, it can be placed there. And now, even with the advancement of robotics and all, you can maneuver or navigate your electrodes wherever you want, exactly to your area of interest, and get this information whatever you want to get. So that is again these are the application with the modalities. And how do we approach that? So some of the basic mathematical aspects I have written here: noise removal, filters, synchronization, averaging. Averaging is specifically used for ERPs, right? Noise removal is like, it's a very important thing to know that what is signal and what is noise. It is quantified by signal to noise ratio. You have some signal. Now alone on noise removal we can talk about R's and R's. Noise can be of two types. One is physiological noise, right? I'll give you one small example of this also. And non-physiological noise. Physiological noise is nothing but generated by humans. Let's say you are taking your EEG from your head or anywhere, but it has some footprint which is like repeated 70-80 times a minute. It is highly possible that it can be a cardiac artifact. Now your heart is connected to brain, brain is connected to heart. This is one example of physiological noise. While going through the recording, a person is moving. Okay. For any EEG recording, currently we have a lot of advancement in computation. However, for any EEG recording, stable the subject, more better the quality of recording. That is why it is difficult to get recording from newborns. There is one aspect or one research from our lab works on newborn hearing screening, which Professor Hardik will cover. So then that there is a physiological type of noise, whereas non-physiological type of noise, this all EEGs and all are of microvolt range, very sensitive, and that's why any external intervention, non-human intervention can deteriorate it. What are they? So that can be a line noise, as simple as that. Our power line noise, if you are generally the room wherever you are should be electrically having a minimal appliances. This is also another aspect of experimental protocol. So then it is also a line noise. How do we mitigate that? Let's say we have a line noise, so you should know what is the power line specification, right? So in India it's around 230 volt, 50 hertz. Now when I say 230 volt, there will be a fluctuation, 220, 230 and all, right? And 50 also can be 49.9, 50.1. How can we remove power line interference? How can we selectively remove that particular component? So for that you have to use filters, right? Filter can be of hardware filter or software filters. Hardware filter means you have a components, it can be active filter or passive filter. Active filter have active components, it will have op-amp. Passive filter will have only resistors and capacitance, right? So that is again a question, which it's a trade-off. It's a problem of hardware software co-design. How do we realize your filter? And like some of the acquisition system has their own filters. Still, if there is any noise, it is always advisable to remove it using your acquisition parameter, using your computational system as well. So there are noise removal techniques, as I mentioned. Filtering is one of them, which I already discussed, and then synchronization, averaging, pattern recognition, which is mainly used for epilepsy screening, and finally time frequency analysis for rodent models. More or less we'll be using it. I will show you one of the example rodents epilepsy model, how this time frequency analysis is being conducted. Feature extraction, very important. Now this feature extraction and pattern recognition is little bit connected. However, there is a difference. Pattern recognition means for, as I mentioned, for epilepsy, Professor Hardik also will cover, we will be checking something called spike, sharp and wave. When I say spike, sharp and wave, it also consists of combination of that. Okay, combinations. So that we will check, and also classification, very important. When I say if you see here seizure classification, so which type of seizure is there? Why it's important? Because therapy differs based on types of seizure. So that is also one of the aspect. Finally we'll see the method what we will be using to get this particular applications. One is GUI based, so there is something called EEG lab. I will put the link in the description, where I will be explaining how to download EEG lab, how to particularly import the data of different format and all, which I have covered in one particular course. In this course we'll see an advanced version of that, how to use the EEG lab for several other applications. And also this all, when I say GUI based processing, it's a pre-designed GUI which is for a general purpose GUI. Okay, whereas suppose you I'll show it to you in the next class how to use this particular GUI. Each GUI or each process for one particular application, let's say hearing screening, will require around 40 to 45 clicks, and some of the information you have to input using your keyboard, right? So how is it advisable that if you have 100 subjects data, you will do GUI for all 100 subjects? It's a time consuming and also prone to human error, right? So can we automate that? So this is our approach number 1, which is GUI, or general purpose GUI. Then there is another approach which is like based on batch file processing. Batch file processing is very convenient also for remote health monitoring. Also, you have 100 subjects data, you just run the script, and you go out, come back, all the results are ready. Just on one click you can forward it to a clinician or neurologist or any concerned person who can interpret and give the impression. Of course, all this, when I say that you have 100 subjects data, on one click you transmit and all follows ethical guidelines. The data whatever you got, when you any subject human data or any subject data, when you transmit it, it should be encrypted and decrypted. So there is something called data security protocols and all. So that again, considering the scope of the course, I will not dive too much into detail for that particular aspect, but it is doable. Further, there is something called custom app development. Okay, this first point number 1 is general purpose, as I mentioned, GUI based processing. Whereas when you have a particular application identified, let's say hearing screening. Now hearing screening, I want to design an app for hearing screening. It has 2 mode. One is for adults, okay, and second one is for newborn or neonate. Now why it is important? Because when the baby is born, baby cannot tell you that I can hear or not. There are some behavioral techniques, but otherwise it's not possible. And if detected on time, you can save baby from lifetime disabilities. So this is just a brief context. There are 2 modes, adults and newborn. What are the parameters you are recording there? So we are recording MMN. Okay, what is MMN and mismatch negativity? That will be covered by Professor Pandya. So I will not go into the detail. Other thing is ABR. ABR is auditory brainstem response, which is a gold standard. What do you mean by gold standard? This is a technique which is currently in use, but MMN gives little bit more information. So these 2 parameters which we are going to record. So if you have this kind of structure in your mind, in your brain, that I will be using only this modality of the brain, you can develop your custom app. When I say hearing screening, these are the 2 parameters. When I say cognitive metrics, let's say I will be recording something called attention and working memory, right? So when you have your things set, when you have your acquisition, when you have your data processing pipeline, everything set, you can go for your custom app development. So in that also there are several types of that. First is dependent on one particular format. Like if you are using MATLAB, you can use it a dependent app which requires MATLAB. Further, if you go make an app which is standalone, you can use Python, or you can use even MATLAB can export finally the standalone app, or you can make a web app only with the one particular link. You can share that link to the doctor, data is taken, loaded into that particular web address, you can get the results. So again, all applications, modalities, approach and method, all possible combinations are there. Okay, all possible combinations means we can use epilepsy seizure classification, let's say using free running EEG. We have to use in that case noise removal technique, filters. We have to identify some patterns as well. You have to do some time frequency analysis. You have to do the classification also, and all this thing can be done using an app using GUI. It can be done using scripting. You can also develop an app which is also 3 of this. So as I mentioned, a lot of combinations are possible and a lot of things can be discussed, but considering the time factor, we will be discussing some of the modalities, some of the demos and all. I'll show it to you that, yeah. So you can see here tentative modules are MMN extraction using EEG Lab GUI, MMN as I mentioned, mismatch negativity. Some sound will be presented, as you can see here. Electrodes will be there to take the data, sounds will be presented, EEG will be acquired, what sound is presented that also will be given to the signal processing module. Both the thing will be acquired by signal processing module, and then you will get this some pattern. Okay, it's slightly blurry, but there will be some patterns for which parameters are known. Again, same thing, this is for ABR, this is for MMN, right. So this is one of the application which I have shown it here, right, and this gets generated within 10 millisecond of sound presentation, and this gets generated around 150 millisecond, 150 to 300 millisecond. Just to give you a context that if you cannot record within 10 millisecond, the signal will go. So it's like electronically challenging to get this kind of signal. How do we do and how to process? We'll see that. Also, as I mentioned, MMN and ABR are here. Also, we'll show you this MMN we will see using EEG Lab GUI. As I mentioned, I'll put the link in the description of how to use EEG Lab and download EEG Lab and all simple steps. Then we'll directly see how we can extract the data using EEG Lab. ABR, I will show it to you mostly with the customized script. Okay, why? I'll tell you at that particular point of time. Also, P300 extraction. P300 is generally used for attention and working memory. Okay, so that we will see using a customized app. We will also have a look at time frequency analysis of epilepsy module. It will be a very short 10-15 minutes module just to give you an idea, and if time permits we will also see the epileptic seizure classification using a script which is, again I am putting it here. So what it does is, you can see here, this is a normal EEG, right, and then you can see a normal baseline with not much variations, whereas during seizure, or I should say generalized seizure, you can see all the channels are showing this uneven traces. So this, how to capture this, and compare to this, how to quantify the difference between this and this, that is nothing but your EEG seizure detection and classification. So based on the time, we will try to cover all the modules of signal processing, and we'll see these are the approaches. I will see you in the next module with this demo. If you have any questions, feel free to write us in the forum. As I mentioned, I'll meet you in the next class. Thank you. Bye.